Today we'll discuss a specific type of sequence, an arithmetic sequence. And these are sequences which have a common difference between terms. So if you look at all my examples here, you'll notice that in the first one, we have from one term to another, and notice how I'm doing this. I go from a term backwards to another term. I have a difference of -1, -10, or -11. Likewise, when I go from my third term to my second term, I'm going from -12 to -1, and that difference is -11. So we say the common difference is -11. You'll see in this second sequence, the difference is going to be an expression rather than a specific number. And if I look and subtract each time, you'll notice the x is reduced, and I have a difference of 3. Whoops. So in actuality, it is a number. In this next example, this is more of an expression. I would take a term and a term before it. So I take x plus 1, subtract off 3x minus 1, which gives me a total of -2 plus 2x plus 2. And then again, if I take third term before it, I get 3 minus x subtracted by x minus 1. You'll notice again I get -2x plus 2. So the difference here, -2x plus 2. So what we're going to try to do now with this sequence is develop an explicit arithmetic pattern for it, or an explicit formula for this specific sequence. Notice I have a common difference of 3 in each case. And if I want to get from this first term to the second term, I take my first term and I basically just add 3. Now if I want to get to the next term, I add 3 as well. So I go from my first term to 2 times my difference. If I want to get to the next term, again, I add 3, or that's going from the first term to 3 times my difference. And I want to go to the last term, and in order to do that, I'm going to have to look at a pattern that's developed between the terms I've already discussed. So notice, if I take a look at this, I have the first term in common in every case. So I'm just going to write down, I go from my first term, and then I've incremented my multiples of that first term by 1 each time. So I have in each case my common difference of 3. And notice my multiple here is 3, my multiple here is 2, and my multiple here is 1. And if you look over at the term we're trying to generate, my subscript is 2 here, and I have a multiple of 1. My subscript is 3 here, and I have a multiple of 2. My subscript is 4 here, and I have a multiple of 3. So you'll see that the multiple is 1 less than the subscript, or n minus 1 in value. So taking that to its most general form, okay, I could say that, well, my first term is 5 plus 3 times the quantity of n minus 1. And then I simplify that out a little bit, and I get my nth term, or my explicit formula, being a total of 3n plus 2. So if I wanted my fourth term, I plug in 4, and I get 12 plus 2 is 14. If I wanted my 100th term, I plug in 100, and I get 302. So this formula will generate any term in this sequence. And once again, that's explicit. In general, for any arithmetic sequence, so for anything that has a common difference, your nth term, or your explicit formula for that term, is equal to the first term plus that common difference multiplied by n minus 1. You'll see a sub n is the nth term, first term is a sub 1, common difference is d, and the number of the nth term is represented by n. So with this formula, we're going to do a couple of problems. We're going to write an explicit formula for the nth term in this sequence here. And we just said that if I want to write the nth term I take my first term plus my difference times n minus 1. Since we're writing just a general formula, n is going to remain n. So I have a sub n equals my first term, which in this case is negative 13, plus my difference. So looking over here, I look from one term back to another, and you'll see that I have a difference of negative 9 minus negative 13, which is equal to my difference, which is equal to 4. So I'll put my 4 where the d is and leave n minus 1. I'd prefer it if you kind of simplify this a little bit, so I have negative 13 plus 4n minus 4, or 4n minus 17 represents the nth term. And once again, I would go ahead and do a quick check. So if I want my fifth term, which I know is 3, I plug 5 in, and I get 4 times 5, which is 20, minus 17 is 3, so it checks out. Now we're going to find some specific terms within our sequences. I know I've got a sequence of 11, 4, negative 3, and I'm looking for my 41st term. Well, if it fits the pattern of the explicit formula, I know that the 41st term can be obtained by taking my first term plus my difference times 41, since that's the subscript matching the n value, minus 1. I know my first term, which is 11. Common difference appears to be negative 7, and I multiply that by 40, and that would give me my 41st term. So this ends up giving me a total of negative 269, and that's my 41st term. Next, we want to find the first term of a sequence where I know I have a common difference of 8, and my 47th term is 229. So let's go ahead and do that. I know my 47th term is equal to my first term plus my difference times, in this case, 47 minus 1. So my 47th term I know is 229. Trying to find my first term. We've got a common difference of 8, and I'm multiplying that by 46. And in this case, we end up with the first term being equivalent to negative 139. Now in this problem, I know the 23rd term of this sequence is 19. So I know a sub 23 is equal to 19. And I know the 31st term is equal to 43. And what I want to do is find the first term. Now there's a couple of ways to go ahead and do this problem. One way is to use this idea of the general formula of a sub n is equal to a1 plus d times n minus 1 and plug in what I know. Again, I'm looking for the first term, so I know the 23rd term, which is 19, is equal to an unknown first term plus the difference, which I don't know, is equal to 23 minus 1. The problem with this is, you'll notice I have two variables, and if I'm going to have two variables, I need two equations to solve it. So the other equation would come from using this term here. In this case, you'll notice I have the nth term of 43 equaling the first term plus the difference times, in this case, it's my 31st term minus 1. So 43 is equal to my first term plus 30d. Now you'll notice I can take and solve this system of equations. Going ahead and doing that, I end up with the following. I get 43 a1 and 30d going to subtract the 2 to get the common difference. So in that case, I end up with negative 24 equaling negative 8d. Therefore, my difference is equal to 3. Once I have a difference of 3, I can find my first term. And I can plug that into either of the two equations that I've already used. So I have 19 equals my first term plus 22 times 3. This gets me my first term plus 66 equals 19. And I end up with my first term equaling negative 47. Now, as I said before, there's another way to do this problem. Again, I knew that my 23rd term was equivalent to 19. And my 31st term was equal to 43. Now, regardless of where these terms are in the line of the sequence, I know there's a specific number of terms between my 23rd term and my 31st term. So I could pretend that this was my first term. I could say let a sub 23 equal the first term. And then I could go ahead and let my 31st term equal another term. If I go from 23 to 1, I've backed up 22 terms. So if I back up 22 from 31, I end up with 9. So that means if my 23rd term is my first term, then my 31st term is my 9th term. And then I can find the difference between each one of these, much like I found the difference in the previous problem. So in this case, I know that my 9th term, 43, in this case, is equal to my first term, which we're now calling 19, plus my difference, times, once again, we're calling this term my 9th term, so 9 minus 1 is 8. And you'll notice going through and solving this, I take my 43, subtract off 19, and I get a total of 24. And that's equal to 8d. D is equal to 3, which is what we got in our previous example. Then once I have a common difference of 3, I can go back and say, all right, well, if I know my difference is 3 and I can use either one of these two terms, I'll say my 23rd term is equal to my first term plus my difference of 3 times 23 minus 1. And if I go through, 23rd term is 19, don't know my first term, I get 3 multiplied by 22, 19 minus 66, once again is equal to negative 47, just like in our last example. So it doesn't matter which way you go about this. I kind of like this way because it avoids a system of equations, but sometimes you're going to have to use a system. It's just a matter of preference. So now we're going to write a recursive formula for this arithmetic sequence, and many times a recursive formula is easier in this case to write than the other. Remember, our recursive formula is based on the fact that we're writing for an nth term and using the previous term to get there. Well, if I look at this pattern, you'll notice that we just have a difference of 7 all the way through. So any term in this can be generated by taking the previous term and adding 7. It's that simple. But remember, you have to be given the first term in order to generate the rest of the terms. So I'd have to say, starting with a first term of 11. That's all we've got. Do your My Math Lab, write your lesson summary out, and we'll chat.